Hello, everybody, and welcome to section 2.4, one-sided limits. So let's get started with this. All right, to get things started, we are going to think back to the unit step function or Heaviside function that we saw just a little bit ago, a couple videos ago. It was this function right here. I believe we used t as a variable before, but now we're going to say it's u of x. And so that function is u of x equals 0 if x values are less than 0, and then u of x equals 1 if the x values are greater than or equal to 0. So we had sketched a picture of this last time we looked at it, and it looks something like this. Okay, here was x versus u of x. And so the idea here was that as long as x is less than 0, the y value, u of x, is going to equal 0. So it was a flat 0, 0, 0, 0, 0, 0, okay, all the way over here. And then as soon as we got to x equals 0, the value was no longer 0, but 1 instead. So this is y equals 1 right there. All right, so u of x equals 1 for all the x's that are greater than or equal to 0. Okay, so this was what the unit step function looked like. And we had looked at this last time and decided that the limit as x approaches 0 of u of x does not exist because our function u of x didn't approach a single value as x approached 0 from both directions. It approached two different values. So if you'll recall, we had started looking at approaching x equals 0 right here. So we would put our fingers on either side of that point and then bring them closer and closer together. And we would see that it doesn't arrive at just a single y value, all right, a single limit there. So we said the limit didn't exist because those two halves just didn't come together. But as you may suspect now, things are going to change. And so we are not going to look specifically at the general overall limit like we were doing before. We are going to look at u of x in terms of one-sided limits. Okay, so we say that as x approaches 0 from the left, so we're going to be coming in from the left here. All right, let's see what happens to u of x. What are we going to be approaching there? So u of x approaches, and let's go up to our graph and look. Okay, so we're still focusing on x equals 0, coming in towards that. But we are going to strictly approach now from the left. Okay, so start one of your fingers, take like your pointer finger and put it to the left of 0 on the function. So like right here maybe. And now we're going to approach x equals 0 coming in from the left. All right. We are totally ignoring this entire other piece of the function. Okay, we don't even know what's going on over there. We're only coming in from the left. So if that's what we're doing, it looks like the limit that we're approaching is going to a y value of 0, right? Staying flat like that because we don't know about this piece when we're coming in from the left. So as x approaches 0 from the left, u of x approaches 0. Okay. And how we are going to notate that, this whole approaching 0 from the left, we've got special notation for this. Okay, so that it makes it clear which direction we're coming from. The notation looks like this. X approaches 0, that's like before, but the new part is this little superscript minus sign. And that means from the left, okay? So you could think of that as like 0 minus a little bit. So a little negative direction there. All right, so that means 0 from the left. Okay. Now, when we put that together with the fact that u of x approaches 0, we get a statement that looks like this. The limit as x approaches 0 from the left of u of x, that limit is 0. Okay, so that's this part coming in right there. U of x approaches 0. All right. Now you might guess what we're going to look at next here. We're going to see as x approaches 0 from the right, what is going on here? U of x approaches, you might be able to guess it by looking at the graph. Let's see if you got it. All right, so coming in from the right, that means we strictly are starting to the right of 0. Okay, so here's our 0 point that we are interested in. We start to the right of that. Okay, so you put your finger on the function somewhere to the right of 0. So I'm going to put my finger on the function right here. And then we are going to let x approach 0. So our finger is going to move towards x equals 0, coming in from the right like this. And we look at the y value that we're approaching in doing that. And it looks like we are approaching this y value of 1. So that is going to be our limit from this side. Again, we don't know what this other half of the function is doing. We are just approaching from the right only in that case. So down here, as x approaches 0 from the right, u of x approaches 1. Okay. And as you might suspect, we're going to have notation for this as well. Okay, so notation for x approaching 0 from the right. Okay, start out with x, the little arrow for approach, approaching 0. And from the right is a little superscript plus up there. So 0 with a little plus. Okay, so that's like thinking about 0 plus a little bit. We're coming in from that direction. So that'd be numbers over here, 0 plus a little. All right. So when we put that together with the result that we got, we would get the statement, the limit as x approaches 0 from the right of u of x equals 1. Okay, so those are our first one-sided limits, one from the left and one from the right. Now, if we compare this with our previous result, remember that when we looked at this unit step function before, we had decided that the overall limit does not exist. These two one-sided limits are actually going to support that. Okay, so to justify our previous conclusion, we can say that since the limit as x approached 0 from the left of u of x did not equal the limit as x approached 0 from the right of u of x, Okay, those two limits were not the same. We didn't approach a single value. We had two different ones. So since this is true, the limit as x approaches 0, okay, with nothing on it there, this means overall limit. Okay, so the overall limit as x approaches 0 of u of x does not exist. Okay, so that's the justification. This is the mathematical way of saying we were approaching two different values from the two different sides. And so we use that to justify the non-existence of this limit. But the individual one-sided limits we can see actually do exist. There's 0 and 1. It's just the overall limit that didn't exist.